Hi, so my name is Jean, and this project is, the members are composed of the people from the Robotics Institute and also the LTI. So we are developing robots that can communicate with the humans using natural language. So far we have done a lot of work using ground vehicle type robots outside. So you can see an example there. So the funds are usually coming from the defense. So the scenarios we are using is navigate to the back of the building in a covert way type. So we have been successfully using that language understanding capabilities in the outdoor robots. And we also applied the language understanding for manipulation robots. So this video, you can see Alexa, Amazon Echo there. So we use that for a student project. So, and this video was taken on a special day when the people bring their kids to work. The children were interacting with the robots using a speech-enabled system. So it was an eye-opening experience for our team because we never thought that using just voice-enabled increases the usability of the robots that significantly. So we were very happy that we tried. So, and this is just this preliminary work. So the command that we use for robots are just pick up some block that's next to the red block or something like that. But so, and this is a Vera robot arm, and the project was just for one semester, so it was a kind of short period of time, but we were able to put that on that mobile platform, Manipulator platform. So the whole language understanding interface is quite platform independent. So, and now we are very excited to work with Professor Ralph Hollis here. So, is it playing? Yeah. So Ralph, do you want to give a short intro? Yeah. So Ralph invented this cool robot called the Ballbot. So Ballbot balances on a single ball-shaped device, and it can move in an omnidirectional way, which gives a great mobility capability for the indoor service robot. So we are planning to have this speech-enabled system on top of this robot. So you can see the robot can navigate through multiple objects, and it can also interact with people using the arms. So Ralph's student is currently working on developing a better manipulation arm. So we will have more than just a stick arm there. And then this is the second generation of the Ballbot, which is smaller and much lightweight. So we are also planning to use this robot. So since we're running out of time, I'll just skip to the next slide. So far I showed the robots from the human's perspective. And this one shows what the robot sees while it's executing the command. So what we are envisioning is robots should be able to explain what it sees and what it's doing and what it has done. So this kind of sketches the view from the robot. So sometimes we don't know when the robots are autonomous, what is it doing? Is it going to hit that building? But once it's being able to explain what it sees, is, for instance, like the scenery or what's in the back of the building, that would be very useful. So, okay, so the capstone scenario, you might think this is a simple task, but in order to do something like, hey, go to the kitchen and tell me what's on the kitchen table, it requires the full understanding of that scenery and also capability to plan for the navigation task and a lot of perception capabilities to recognize the objects and distinguish different types of objects as well. So the techniques that are still need to be developed, or we really need to work hard, is really improving the technologies for language understanding and language generation, and also the robot capabilities as well. So in summary, as I mentioned, this having the voice system on the robot, it just changes the whole perspective on the robot. So it really revolutionized the use of the robot in the field. So I guess that's it. So thank you so much. Okay, any questions?
Yeah, it's super interesting. I mean, combining the fields of robotics with speech processing, a lot sort of going on there.
So can I just make a remark for a second? So we strategically really believe that it's the time for marrying together this smooth, beautiful motion technology based on the Ballbot with things like face recognition, with computer vision and speech. Now's the time to do it. It's going to happen.
Yeah, and certainly in my travels, I see a lot of innovation happening in this very area. As it relates to the sort of the speech interaction piece of it, the demonstration of giving commands to the arm and translating those into actions that the robot does, that seems to make sense and is in the spectrum of everything you're doing relatively straightforward. Could you talk to me a little bit more about what you described as vision language translation? I wasn't sure I fully understood that.
Yes, so as you saw, what the robot saw during navigation, it sees a lot of imagery input. So from that visual input, that has to be translated into language. So, I see there is a steps to the back, and this room has like 4 or 5 rows of the chairs, and their kind of texture is wooden type. So you can describe the imagery, visual input in natural language.
I see. So it's beyond just a CV-based classification of an object into a more detailed.
Right. So in the computer vision side, the generating description or image captioning is relatively new.
Yeah.
But it's making big progress these days. But the results you see in like Google image caption examples, it can be just anything you pick on that image. But in this task-specific domain, the generated language should be concise, and informative. So picking the right type of landmark or the type of objects to use in that generated sentences, that's the important challenge to deal with. So.
Cool.
Thank you.
Fascinating.